What is the direction of net force? Right side. So acceleration is also right side. If 1 Newton is right side, 3 Newton is left side. What is the acceleration? Tell me. 3 minus 2. Sorry, 3 minus 1 by m. So 2 by 2, 1. And what is the direction of acceleration? Right or left? Left. Very good. Direction is left. Now suppose 1 Newton and here root 3 Newton. Now can you tell me how much is acceleration? Now this is 90 degree. So resultant force we find. Resultant force. What is the resultant force? Square root of root 3 square plus 1 square. So how much? Square root of 4. Correct. So root 4 means 2. So net force is 2. So what is the acceleration? Mass is 2. So what is the acceleration? 1. Very good. And what is the direction of acceleration? Along the net force. Very good. So this is the direction of acceleration. Okay. This is the direction of acceleration. If I ask what is alpha, so how will you tell alpha? Tell me. What is tan alpha? What is the opposite? By adjacent. Opposite, how much? Root 3. Adjacent? 1. So tan alpha is 1 by root 3. So what is alpha? 30 degree. Okay. 30 degree. So this object will move 30 degree north of east. You can say 30 degree north of east. Okay. This is what direction? What is this direction? East. This is north. And alpha is 30. So what is this direction? What do you call this direction? What do you call this direction? 30 degree north of east. Means 30 degrees measured from east. 30 degrees measured from east. Or suppose this is 60. So you can also call it 60 degree east of north. Very good. 60 degree east of north. Okay. Means 60 degree measured from north. Correct. So the understanding, what is understanding here? Acceleration is along net force. Acceleration is along net force, and acceleration is equal to net force by mass. Okay. Acceleration is net force by mass. Magnitude you can calculate. Okay. Now suppose one force is right side, 1 Newton. Another force is left side, 0.5 Newton. Another force is downward, 6 Newton. Another force is upward, 2 root 3 Newton. 2 root 3 Newton. Okay. Mass is 2 kg. Find acceleration with direction. You can use north, south, east, west. Okay. So this is north, this is south, this is east, this is west. Okay. North, south, east, west. Okay. Calculate. So how many forces you see? How many forces? 4 forces. Correct. 1, 2, 3, 4. So when you have opposite direction forces, you can use difference. Like for example, right side 2, left side 1. So what is the resultant of these two? 2, 1. Okay. 2 minus 1. So now these are opposite. So what is the resultant? These are opposite. So what is the resultant? 1. Correct. So 1 minus 0.5. So you can write 1 minus 0.5. So 0.5. Then 2 root 3 and 6. Then which is greater, 2 root 3 or 6? 6. So what is the resultant here? 6 minus 2 root 3. Correct. Now this is 0.5 and this is 6 minus 2 root 3. Again complete the parallelogram. So this is the net force. This is the net force. Okay. So these two forces, you have found the resultant. 0.5. These two forces, we have found the resultant 6 minus 2 root 3. Okay, 2 root 3, you know, 2 into 1.7. So 3.4. So 6 and 3.4. 6 is greater. 6 is greater. So what is the resultant of these two? 6 minus 3.4 means 6 minus 2 root 3. Now you tell what is alpha. Tell me what is alpha. So you can use tan alpha is equal to, tell me what is tan alpha. Opposite by adjacent. What is the opposite? Opposite to alpha, what is this length? 6 minus 2 root 3. Adjacent, what is the value? 0.5. Okay, 0.5. So this is the value. So this you can write 1 by 2. So 6 minus 2 root 3 divided by 1 by 2. Okay, so you can say 6 minus 2 root 3 into 2. 6 minus 2 root 3 into 2. So 2 also you can take common. So 2 into 3 minus root 3 into 2. So 4 into 3 minus root 3. Okay, clear? So what is tan alpha? 4 into 3 minus root 3. I will give one better value question. Okay, next. So this is the acceleration. This is how. So what is the acceleration? Tell me. What is the net force? What is the net force? See, you can write in IJ form also. What is the IJ form here? Tell me. What is the net force in IJ form? 0.5 I cap. And what is this? Minus 6 minus 2 root 3 J cap. Okay. So like this also you can say this is the net force. This is the net force. So acceleration will be net force by mass. Okay. Wait, I think I have given some difficult values. Wait, I will change the values. Wait, then you try again. Okay, let's take right side 2, left side 1. And this is 2 root 3 and this is root 3. Okay, now you solve. So what is the resultant of 2 and 1? 2 and 1 resultant? 2 and 1 which is greater? 2. So what is the resultant of 2 and 1? 1. Where? Right or left? Right side. Value? 1. 2 root 3 and root 3 which is greater? 2 root 3. So what is the resultant of these two? 2 root 3 minus root 3. So how much? 2 root 3 minus root 3. How much? Root 3. Very good. Because 2 minus 1 is 1. Okay. So now you have one component north side, another component east side. So what is the resultant force now? Okay, this is the resultant. This is the net force. Now you tell me what is alpha. Tell me. So what is tan alpha? How much? Tell me. Opposite. What is opposite? Opposite. Root 3. Adjacent. 1. So what is alpha? 60 degree. So how will you write the direction? How will you write the direction? 60 degree north of east. Okay, 60 degree north of east. So force. So net force is along 60 degree north of east. Okay, 60 degree north of east, and acceleration is along this only. Also acceleration. So what is the direction of acceleration? 60 degree north of east. Net force is where? Acceleration is there, remember. Okay. So acceleration is along net force, remember, or you can say net force is along acceleration. Suppose you see acceleration is along east, so that means net force is along east. If you see acceleration is along north, so that means net force is along north. Okay, remember. acceleration and net force, parallel vectors. They are parallel vectors, they are same direction. Okay, okay, fine. So this is known as free body diagram, correct? This is known as free body diagram. Free body diagram represents forces with common tail. Okay, free body diagram means forces with common tail. Forces with common tail. If only one force is there, then only one force. Two forces there, like this, two forces. Three forces there, it may be like this. Four forces are there, like this. It can be five forces also. One, two, three, four, five, with common tail, right? So number of forces can be anything. 2, 3, 4, 5, 6, 7. Okay, but common tail. So free body diagram. Free body diagram. Okay, understood? Clear? Okay. Some more examples. Now, see, you answer this question. This question is very basic. Okay, very easy also. Think like that. It is very easy. Just try to understand the meaning. When 6 Newton X, when only means single force, particle accelerates along east with 4 meter per second square. Find acceleration when 3 forces X as 4 Newton west, 2 Newton south, 6 Newton north. Find acceleration with direction. Find acceleration with direction. Okay, so sometimes in question they will ask magnitude, sometimes in question they will ask direction, sometimes in question they will ask both magnitude and direction. So you should know how to calculate both magnitude and direction. Half knowledge is not good. Are you getting? Suppose you know how to find magnitude but you don't know how to find direction, it is incomplete. Okay, you should know both, how to find magnitude, how to find direction. So tell me, you have to find magnitude and direction. So draw diagram. Okay, draw diagram. So what is the given what is the given condition, what is the given situation, information, what is the information given? 6 Newton east, so particle acceleration is 4. So you can write when 6 Newton is along east, mass is m, mass is m. So what is the force? 6 Newton, mass is m, acceleration is 4. So F is equal to ma. So calculate mass, tell me. So 6 is equal to m into 4. So what is m? 6 by 4. So 3 by 2. Now how many forces? 3 forces. So draw this. So 4 Newton west, 4 Newton west, common tail. Okay, 2 Newton south, 2 Newton south with common tail. 6 Newton north, 6 Newton north. Now find resultant. North of west or east? West. Okay. See, don't find resultant of 4 and 6. First you find resultant of 6 and 2. Why? Because it is they are opposite. What is easy to find? When when the vectors are opposite or when vectors are 90-degree, what is easy to find? Resultant, what is, in which case resultant is easy to find, one or two? First case resultant is easy to find, correct? So identify the opposite vectors. Find the opposite vector. Which are opposite vectors? Opposite vectors. 6 and 2. So what is resultant of 6 and 2? 4. Very good. Resultant of 6 and 2 is 4. So 4 will be where? Up or down? Up. So resultant of 6 and 2 is 4, and this 4 is there. Now what do you think? What is the direction of resultant? This is north, this is west. Both are equal. So what is the direction of resultant? What is this direction? Northwest. Northwest. Okay, 45-degree, right or not? So this is northwest. So net force, tell me what is net force? 4 and 4, 90-degree. What is the resultant? Tell me. 4 root 2. Very good. 4 root 2. So this is revision of vector, right? So you know this concept. Suppose F and F parallel. What is the resultant? 2F. F and F anti-parallel. What is the resultant? 0. Very good. And if F and F were 90-degree, what is the resultant? Root 2F. Okay. F and F 60-degree. What is the resultant? F root 3. F and F 120-degree. What is the resultant? F. 90-degree means what is the resultant? F root 2. 60-degree means what is the resultant? F root 3. 120-degree, what is the resultant? F. If theta degree is there, theta degree, if F and F angle is theta, what is the resultant? 2F cos theta by 2. Okay, resultant. Okay. So here 4 and 4 both are equal, and what is the angle? What is the angle? 90. So what is the resultant of 4 and 4? 4 root 2. Correct. So net force is 4 root 2. Now net force is mass into acceleration. What is the mass? We calculated mass. How much mass? 3 by 2. So what is the acceleration? Tell me, what is the acceleration? 8 root 2 by 3. Okay, 8 root 2 by 3. Note down. 8 root 2 by 3 meter per second square. Okay, this is the acceleration. Note down. And what is the direction of net force? Northwest. So what is the direction of acceleration? Northwest. Acceleration and force same direction. Okay, if force is northwest, so acceleration also northwest. I gave one example of chair. So force is here. So where chair is going? Here. If force is here, so chair is going there. Now force is both direction. Here also force, here also force. Now where the chair is going? See, here it is going. Understood? If I exert one force here, where the chair will go? Correct or not? Okay, it is coming like this. Okay, so northwest. Okay, done. Note down. Acceleration is along net force, remember. So this is 4, this is 4. And net force is equal to ma. Net force is mass into acceleration. Net force, how much is net force? 4 root 2. So 4 root 2 is m into a. M is 3 by 2 kg and acceleration a. So 8 root 2 by 3 acceleration. Okay, clear? Okay, done. Now next question. When force is F, acceleration is 1 meter per second square. Find acceleration if three forces are acting as shown. Draw this diagram. Now this is the question. How many forces? Three forces. One, two, three. What do you think about these forces? These forces, what type? Opposite. So find resultant of these two. 2 root 2 and root 2. Root 2 where? This way or this way? This way. Correct. Then you have this one. What is the angle between these two? 6. How much? 90. Correct. This is 60. So this is 90. Okay. See, this is 60. So 30, 30, 60. This is 30. So this is 60. 60 plus 30, 90. So this force and this force 90 degree. Now here root 2, here root 2. So what is the resultant? Complete the parallelogram like this. This is the resultant. Okay. So what is the resultant? Tell me. Root 2 and root 2 at 90 degree. So what is the resultant? Root 2 and root 2 at 90 degree. So what is the resultant? Previous page we have discussed here. F and F 90 degree. What is the resultant? F root 2. Now you have root 2 at 90 degree. So what is the net? Root 2 into root 2. Correct? So 2 Newton. So 2 Newton. So force is 2 Newton. Okay. So suppose if I am writing here 2 root 2 F. If I am writing here 2 root 2 F. Here also I am writing root 2 F. And here root 2 F. So here I will write root 2 F. Here root 2 F. So what is the resultant now? What is the resultant? Root 2F and root 2F. Root 2 times of root 2F. Root 2 times of root 2F means 2F. Okay. Done. See, once again, F and F 90 degree. What is the resultant? F root 2. Now, root 2F and root 2F at 90 degree. So, what is the resultant? Root 2 times of root 2F. Okay. Suppose you have X 90 degree. So, what is the resultant? X root 2. So, root 2F 90 degree. So, root 2 times of root 2F. Root 2 times root 2F means 2F. Now, F is producing what acceleration? 1. So, 2F will produce what acceleration? 2. Correct. Very good. So, acceleration is 2 meter per second square. And direction, tell me what is the direction? What is this direction? North. So, direction is north. Direction is north. Correct. Oh, sorry. No, not north. You tell me what is the direction? Not north. Direction is not north. It will bisect this angle. It will bisect this. This is 30. This is 60. So what is the direction of acceleration? It will measure 45 degree from here. Measure 45 degree from here or 45 degree from here. So what is the direction? Direction will be, this is the north direction and this is 30. This is 30 degree. Now 45 we have to measure from here. So what is the direction of resultant? Now this will be 15. Okay, so this is the direction of resultant. Okay, so I will change here also. Root 2f here. Another root 2f is here. It will be like this. Okay, somewhat like this. With north direction, it is making what angle? With north direction, what angle it is making? With 15 degree. Okay, 15 degree. So this is 30. So this is 60. So and both are equal. Okay, root 2f here, root 2f and root 2f. So this angle will be 45. This angle will be 45. And this angle is 30. This is 30. So this will be 15. So what is the direction of resultant? 15 degree east of north. 15 degree east of north. 15 degree east of north. Okay, note down. 15 degree east of north. So acceleration is 2 meter per second square. 15 degree east of north. 15 degree east of north. Note down. See, when forces are equal, give me one pen, any pen you need. Okay, no problem. One more. So this now two forces are like this. What is the direction? Tell me. North, east. So what is this direction? So this is northeast. This is northeast. Now two forces are like this. What is the direction? Northwest. Now this situation, it is like this. This vector is rotated by 60 degree. Okay, like this. See, it is rotated by 60 degree. So resultant will also rotate. Okay, like this. So now this is the resultant. Okay, this is the resultant. This is the resultant. So what is this angle? This angle 45. This is 30. So how much is this? 15. Okay. So 15 degree east of north. Okay. 15 degree east of north. Okay. Now next, answer this. Yesterday also one student asked doubt based on this. Suppose this is F, this is F. What is this direction? East. This is north. And one vector is here, F. This is 45 degree. If mass is m, find acceleration. This force is northward, this is east, this is southwest. Southwest. So how many forces? How many forces? 3 forces. Take 2 at a time. Which 2 you can take easily? Easy calculation. North and east. See, resultant you can find easily because what is the angle? 90. and direction will be this. So F and F, what is the resultant? Root 3F. Sorry, root 2F. Root 2F. F and F resultant root 2F. And then third force F. Now F and root 2F are anti-parallel, opposite. They are opposite. So what is the resultant? Which is greater? First you tell which is greater? Root 2F. So what is the resultant? Difference. Root 2F minus F. So root 2 minus 1 into F. Root 2 minus 1 into F. Note down. Root 2 minus 1 into F. Okay. See, three forces are there along north, along east, along southwest. So, note down. Identify the two easy forces. Like previous question, I am going back again. Previous question, which two are easy here? These two are easy, opposite. So 2 root 2 minus root 2. 2 root 2 minus root 2 is root 2. Then this root 2 and this root 2 at 90 degree. So what is the resultant? Root 2 times of root 2 F. Okay. So identify the easy here. Which two are easy to find? These two, 90 degree, because when you calculate F and F 90 degree, it will be F root 2 along 45 degree, F root 2 along 45 degree north of east. So now you have northeast here, this is northeast and this is southwest, they are opposite, so greater minus smaller, so root 2 minus 1 into F. Okay, identify the opposite forces. Okay, opposite forces. So what is the answer now? Tell me, what is the answer? Find acceleration. So net force is equal to mass into acceleration. Mass into acceleration. So acceleration is equal to root 2 minus 1 into F by m. And what is the direction of resultant force? Tell me, resultant force is where? What is this direction? This is northeast, right? This is northeast. So what is the direction of acceleration? Along northeast. Along northeast only. Okay. Acceleration and net force, same direction. Remember. Okay. Good. Very good. So understand this first. Okay. Again, I am telling laws of motion is the basics. Okay. It is, these are the basics of laws of motion. And vector also. So many of you understand this. Okay. If you are not understanding, you try to understand. Ask doubts. Okay. Now 3-4 questions I have solved. Once again you go through it during the study hour. Any doubt is there? Any step is there? You ask. Okay. Now I am moving ahead. Okay. Fine. So what I discussed till now? Acceleration is along net force. Direction of acceleration is along net force. Okay. Okay. Fine. Now let's go back to our topic. Newton's second law, unbalanced forces. So yesterday we discussed blocks. Okay. 2 blocks. So let's discuss next topic, pulley. Let's discuss pulley. Note down pulley and surface. Pulley and horizontal surface. Pulley and horizontal surface. And 2 blocks. Okay. Two blocks and pulley and horizontal surface. This is the pulley, it can rotate. but this is a smooth pulley. Now one block I have fixed here. This is the string. Another block I have fixed here. First you draw this diagram. See the diagram first. Very important. What type of surface? What type of surface? Horizontal. Okay. Smooth surface. Frictionless. So one block M1 is kept on the surface. Another block M2 is hanging. It is hanging, okay, with the help of string. One end of a string is connected to M1, other end of a string connected to M2. And this string is going over the pulley. This part of the string is horizontal. This part of the string is vertical. And this is smooth. Okay. Now I will discuss about some practical example. Let's put elephant here, okay, and rat here. I will come back there. So here elephant is there, okay. So okay, elephant is there, and here rat is there. One rope is there, it is connected to elephant, other end of the rope is connected to rat. So what will happen? It is smooth. Elephant will move or not? It will move. Why? Because surface is smooth. So rat is very light object, but still weight is acting on rat also. Maybe the mass of the rat is in grams, 10 gram, 20 gram, right? So mg is acting on the rat. Where mg is acting? M2g. Okay. So M2g is acting where? Rat. What is the mass of rat? M2. So M2 is acting down. Tension is acting where? Upward. Now for the pulley, tension is acting where? Downward. Here, left. So one tension is acting down, another tension left. For elephant, tension is where? Right. Correct. So this, because of this tension, elephant will move right side. Is there any opposing force back side? No. Friction is not there. It is smooth. Okay. So it doesn't matter how much force is there. A small force or large force, it doesn't matter. Elephant will move. Okay. So because there is no opposition, no friction is there. Okay. So same thing here now. So here you draw free body diagram M2G, here T, and for this you draw T right side. So upward force normal, downward force M1G. So this is the free body diagram for block, and this is the free body diagram for M2. Hanging block, you can call it hanging block. This is hanging block, and this is resting, or no, resting is not correct word. You can call it on the surface, block on surface, block on surface. Two blocks are there. One block is hanging, other block is on the surface. Correct? It is sliding. It is sliding. Block, this M1 will slide where? Right side. M2 will go where? Downwards. Correct. Not down. So acceleration you assume, this is the acceleration. Acceleration is downward A. So what is the acceleration of M1? rightward A. Same acceleration. Tell me why same acceleration? Why same acceleration? Because they are connected by string. So suppose it is going down by 1 meter, so this will go right by 1 meter. If this go down by 2 meter, so this will go right by 2 meter. So whatever is displacement, here also same displacement. Whatever is velocity here, suppose it is going down with 1 meter per second. So here also velocity will be 1 meter per second. Okay. So similarly, acceleration. So acceleration of both block will be equal in magnitude. Remember, magnitude only equal, direction not. Direction of this is downward, direction of this is right, or you can say this is minus j and this is plus I. Okay. So what is the acceleration? Same acceleration. Magnitude is same, A. Now which is greater force, m2g or t? m2g is greater. So what you write here? m2g minus t is equal to m2a. Very good. Here what is the unbalanced force? T. Very good. So T is equal to m1a. Now this is the first equation. Second equation. Add these two and add 1 and 2. What you get? Add 1 and 2. T minus T. What is that? Cancel. So T plus m2g minus T is equal to m1a plus m2a. Okay. So T cancel. So m2g is equal to m1 plus m2 bracket close into a. So what is the formula for acceleration? m2g by m1 plus m2. Note down. m2g by m1 plus m2. m2 is hanging mass. Remember, hanging mass by total mass into g. So this short trick you can memorize. Hanging mass by total mass into g. So what is the acceleration formula? Hanging mass by total mass into g. Note down. So copy this, and what is the tension value also you calculate. Tension value here. So using equation 1, what is the tension value? m1a, and a is this. What is a? m2g by m1 plus m2. So what is tension now? Tell me. m1 m2g by m1 plus m2. So this is the tension formula. So how you can memorize like this? So you can memorize like this. Tension is equal to product G by sum. Product G by sum. Okay, product means multiply masses m1 m2 into G by sum m1 plus m2. Are you getting? So the blocks are going like this. Okay, blocks are going like this. m2 is going down, m1 is going right. So acceleration you got, tension also you got. So let's do one question. Acceleration is hanging by total into g. Tension product by sum into g. So now you solve this question. Here suppose 1 kg, here pulley is there, here 3 kg. What is the tension and what is the acceleration? Tell me. You can check the formula. Then acceleration hanging by total tension product G by sum. Acceleration hanging by total into G tension product by sum into G. So what is the hanging mass? Tell me. 3 total 4. So 30 by 4 7.5. Very good. 7 point. No 7 point. 7.4. Correct. And how much is tension? Correct. So 3 into 1 3 by sum 3 by 4 into 10. Same answer. 7.5. If I interchange the masses, here 1 kg, here 3 kg. Now what will be the tension? Tell me, and what will be the acceleration? Interchange, swap. So what is the tension? Tell me. Tension product by sum into G. So tension value is same. Acceleration hanging by total into G. 10 by 4. So 2.5. Note down. Okay, clear. Note down. Copy this. So understand this. Okay. So understand this formula. Very important. What is the situation? What is the problem? Horizontal surface, pulley, 2 blocks. One is hanging, other is on the surface. Any friction? No friction. Smooth. It doesn't matter which heavy or less. This will compulsory. It is always this will move. Rat and elephant we have taken example. So rat can pull elephant. Okay. Rat is very small object. Elephant is very heavy. So rat can pull elephant. Why? Because smooth. Okay. Surface is smooth. So note down. And what is a normal force formula? What is a normal force here? That also you write. How much is normal force? N is equal to m1g. Okay, here only you write m1g. Okay, clear. They are balanced. Balanced. Okay. Now 3 blocks. Next you write down 3 blocks. One block here m1, another block here m2, another block here m3. Okay. Two pulleys. Two pulleys. M1 is on the surface, horizontal surface. M2 is hanging. M3 is hanging. Okay. So M3 is greater. M3 is okay. Let's take M3 is equal to M2. What will happen? Tell me. If M3 and M2 are equal, tell me. Both are equal. What will happen? Rest. So equilibrium. So note down. If M3, M2 equal, then system is in equilibrium. Forces are balanced. Forces are balanced. Forces are balanced means if they are at rest, so always at rest, continuously they are at rest. Because M3 will pull M1 left and M2 will pull M1 right, and both are equal. So no one is winning, no block win, they are not winning. So tug of war. Okay. So next you write down. So tug of war. Suppose this is 1 kg. So what is the weight? 10 Newton. 1 kg. What is the weight? 10 Newton. So here 10 Newton, here 10 Newton. Cancel. So rest. Equilibrium. M3, M2 equal. Okay, understood? Clear? Okay. Now next you write down. Again you draw the same diagram, or you just write. You just write. Let's take M3 is greater than M2. Now what will happen? M3 greater than M2. M3 greater than M2. Now what will happen? Which will go up? M3 or M2? Which will go up? M3 greater. Correct, good. M3 greater means heavy. So M2 will go up. M3 down. So acceleration of M3 will be downward A. Acceleration of M2 will be upward A. And M1 will go where? Left. Good. So this is one string, other string. These two strings are same or different? Different. So both are different. So one tension here, see here, T1, 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 T1. Now this is second string, tension will be different. Here T2, T2, okay, T2, T2. This string is pulling M1 where? Left. This string is pulling M1 where? Right. The same string is pulling M2 where? Up. This string is pulling M3 where? Upward. So what is the downward force here? Downward force? M3G. Very good. Upward force T1. So what you write? M3G minus T1 is equal to MA. Net unbalanced force is equal to mass into acceleration. Note down. For this what you write? Left side is T1, right side is T2, upward is normal, downward is M1G. So this is greater. So what you will write? T1 minus T2 is equal to M1A. Net unbalanced force is mass into acceleration. Correct or not? Now similarly you write for this. Tell me what you write. Which force is greater? Mg is acting where? Tell me. Mg is acting where? Downward. M2G. T2 upward. Where is acceleration? Upward. So which is greater? T2 greater. So what do you write? T2 minus M2G is equal to M2A. Now this is first equation. Now solve these. Add all these three. Add these three. Add these three. Okay. Add what you get. Tell me. m2, m3 minus m2 g. Okay, good. So add. Okay, you have to add these equations. When you add these, minus t1 plus t1 cancel, minus t2 plus t2 cancel. So what is left? m3g minus m2g. m3g minus m2g is equal to, right side what you get, m3a plus m1a plus m2a, m3a plus m1a plus m2a. Note down. G common, m3 minus m2 into g is equal to m3 plus m1 plus m2. So m1 plus m2 plus m3 into a. Okay, so this is the answer. Correct. Good. Very good. So how you will memorize this? Difference of hanging, difference of hanging, m3 minus m2 by total sum. Okay, difference by total sum, difference of hanging into g. Okay, difference of hanging. Hanging means, you understand hanging? Hanging like this, it is hanging. Okay, hanging. This is known as on the surface. This is on the surface. This is hanging. Like fan. Fan is hanging. Table is on the surface. Computer is on the surface. Correct? That camera is hanging. Okay, correct. Good. So M3 and M2 are hanging. M1 is on the surface. Okay, fine. So fine. Good. Now T1 and T2. So you substitute a value, you will get T1. Okay. Okay. Now next, I am giving question. I am giving question now. Now use these three equations to solve. Okay. Now I am giving questions. Substitute a value here, you will get T2, and substitute a value here, you will get T1. Okay. Don't solve here. In question you solve, because everything you will get in terms of M1, M2, M3. No, this is enough. Acceleration is okay. Now question you write. Okay, solve this question. Okay, here 2 kg, here 1 kg, here 3 kg. Okay. What is the acceleration? This is string 1. This is string 2. What is tension in string 1 and tension in string 2? So acceleration you can directly tell difference of hanging by total sum into g. What is difference of hanging? 1. 2 minus 1 by total sum, total 6 into g. So what is the acceleration? 1 by 6 into g. Now how to find T1? You draw diagram now. So here what is the upward force? T1 downward force 20. Acceleration where, up or down? Acceleration downward. Very good. So which is greater, T1 or 20? So 20 is greater. So 20 minus T1 is equal to 20 minus T1 is equal to MA. So 20 minus T1 is equal to A. A you got. Correct. So 5 by 3. Okay. Acceleration is 5 by 3. So 20 minus 10 by 3 is equal to T1. So I am doing here. So T1 is equal to 20 minus 10 by 3. How much? 60 minus 10. 60 minus 10, how much? So how much is T1? 50 by 3. Now come here. So what is the upward force here? T2, downward force, mg. Which is greater, T2 or mg? Acceleration is where? This is going up. So acceleration is up. So which is greater, T2 or 10? Which is greater? T2. So what do you write? T2 minus 10 is equal to ma. A you know, 5 by 3. Acceleration is 5 by 3. So tell me, what is T2? 10 plus 5 by 3, how much? 30 plus 5 by 3. So 35 by 3. Okay, note down. 35 by 3. Okay, okay, note down. See, carefully observe calculation. Okay, you see which force is greater, up or down, which force is up is greater, so it will go up. Down is greater means it will go down. Okay, so it is going down. So 20 is greater. So 20 minus T1. This is going up. So T2 is greater. So T2 minus 10. Okay, unbalanced force. Unbalanced force. So tension on string 1 is 50 by 3 Newton and tension on string 2 is 35 by 3 Newton. Okay. Okay. Newton is the SI unit of force. Okay. SI unit. Okay. Clear? Understood? You practice this again and again. Okay. This is mechanics. Okay. Mechanics is the part of physics. Okay. Mechanics you have to understand very well. If thoroughly you can understand mechanics, so okay, 160 plus you will get. Okay, 170, 180. Okay, if 60% also, if you are understanding, 100%, 120 plus you will get, 130 something. Mechanics is the main concept of physics, main core. Okay, up to gravitation is mechanics. Motion in 1D, motion in 2D, laws of motion, work for energy. What is the next chapter? System of particles, collision, right? Collision. After that, rotational motion, right? Rotational motion. After that, gravitation. Okay. Up to gravitation, it is mechanics. 5, 6 to 7 chapters are there. So that is mechanics. So we are doing. We'll cover mechanics very deeply. Okay. Thoroughly we will cover. So this is how many blocks? 3 blocks. Okay. Next you write again 2 blocks. Let's come back to 2 blocks. But one is inclined plane. Note down. 2 blocks. One block on inclined plane. One block on inclined plane. M1 is on inclined plane. M2 is hanging. This is the clamp. Okay, so pulley you can assume this is the pulley. Yesterday we discussed inclined plane. Suppose this is the inclined plane. What is the acceleration? The block is this. This is the block. How much acceleration you know? G sin theta. Very good. We discussed this yesterday. Normal mg. Remember this question? This is theta. So this is theta. 90 minus theta. Theta. Okay. Okay, you are taking components. So what is the component of mg? Parallel, parallel to surface, parallel to surface. Mg sin theta, perpendicular to surface, mg cos theta. Okay. So this mg sin theta will pull it down. Okay. Mg sin theta is pulling it. So what is the acceleration? G sin theta. Acceleration is G sin theta. Now come here. So here what is the force? What is the force down the plane? Down the plane, what is the force here? Mg, M1g sin theta. M1g sin theta is pulling it down. And here what is the force? Tension. And for M2, downward force, tell me. Downward force, M2g, very good. Upward force, tension. Okay, clear. Are you getting? What force is pulling it? In, in inclined plane, what force is pulling it? Inclined plane, what force is pulling it down? Mg sin theta. Okay. Here, what force is pulling it down? M2g. Here, M1g sin theta. So, M1g sin theta is pulling it down here. Here, M2g is pulling it down here. Now, they will move like this or they will move like this. How you will check? How you will check that M2 is going down, M1 is going up, or M1 is going down, M2 is going up? How? How you will check? How to check? Tell me. Which block? How to check which block going up and which block is going down and which going down? Not down, not down. Very important. Not down. How to check? Okay, because to understand concept, this is important to understand, right? We will use this in friction also. Okay, friction chapter. So two blocks and surface is smooth. Okay, I am not writing again and again. Surface is smooth, frictionless. Surface is smooth, frictionless. Okay, fine. Okay. So inclined plane block, when one block is inclined plane, mg sin theta is compulsory. It is there always. Like here, mg sin theta is there. Okay. So this block is on inclined plane. So mg sin theta is there, pulling it down, but it is connected to string. So tension. Now this is hanging block. Downward is M2g, upward is tension. Okay. Then my question is, how to check which block will go up and which block will go down? So note down. You calculate this and calculate this. If this is greater than this, so this will go down and this will go up. Understood? If this is greater than this, then this will go down, this will go up. Okay, clear? Note down. If M1g sin theta, okay, if both are equal, then what will happen? Then balanced, no one will move. They are in equilibrium. They are, so that is equilibrium. Okay, are you getting or not? Like this one, we discussed that three blocks, remember? If these two are equal, so they are in equilibrium. Now similarly you can answer, what force is pulling it down? This. What force is pulling it down? This. If both are equal, so they are in equilibrium. That means M1g, sorry, GG cancel, m1 sin theta is equal to m2. If m1 sin theta is equal to m2, it means they are in equilibrium. If m1g sin theta is greater than m2g, or you can say m1 sin theta is greater than m2, which block will go down? Tell me. Which block will go down? m1 will go down, m2 will move up. So m1 will slide, it will slide down, m1 will slide down, m2 go up, m2 go up. Okay, clear? Are you getting? Huh? Okay, note down. See, laws of motion is purely based on tug of war. Okay, that rope, one game is there, tug of war. Okay, who will win? Some students are pulling this here, some students are pulling it here. Who will win? Right or not? If more force here, the chair will go here. More force here, chair will go there. Okay, like that. So here pulling force is more than this, so they will move like this. If more pulling force here, they will move like this. Okay, clear? So, okay, understood? So calculate this. Okay, fine. Then what equation you will write? Tell me. Suppose acceleration is a. What you write? Suppose acceleration here is a. So what is acceleration here? A. So what you write? Tell me. What you write? This minus this. m1g sin theta minus t is equal to m1a. And for this, what you write? T minus m2g is equal to m2a. Okay, easy, right? Easy. Just observe the pulling force. This is known as pulling force or pull force. Here pull force is m1g sin theta. Here pull force is m2g. Compare which is greater. If both are equal, equilibrium. If this is greater, this will go down, this will go up. If this is greater, then this will go down, this will go up. Okay, they will move. Okay, clear? Huh? Huh. Okay, good. So now solve the question. Copy. First you copy. Copy. Write down formula. m1g minus m1g sin theta minus t is equal to m1a. T minus m2g is equal to m2. Now I will give question with values. Okay, 2 kg, 3 kg, 37 degree, like that, 60 degree, 45 degree, some angle I will give, mass I will give. Okay, clear? Okay, clear, done? Copied? Copy this. You can just draw these two forces, m1g sin theta t, m2g sin theta t. Okay, now you answer this. This is 2 kg. This is 30 degree. Here 1 kg. True or false? True or false? Blocks are not in equilibrium. blocks are in equilibrium? Tell me, true or false? First is false. Okay. So second is true. Okay. 1 kg will move up. 2 kg will move down, down the plane. 2 kg will move down the plane. If you want to check again, you can check again. Okay. And I will suggest you watch the video once again. Okay. See, we have to finish our syllabus by November 30 also. Okay. So, and also I want to cover everything. So 3 to 4 hour I am taking daily. So then okay. Okay. So what is mg sin theta here? What is this force? 2g sin 30, 2n sin 30, sin 30, 1 by 2. So g. And what is the pulling force here? G. Both are equal. So they are in equilibrium. So second is correct. First is false. Third is false. Fourth is also false. Okay. 1 kg will move up. No. 2 kg will move down. No. Okay. No. Not down. Now interchange these. Next question. 1 kg here. 2 kg here. Next question. This is 1 kg. This is 2 kg. Okay, now you solve this. Interchange. Angle this 30 on. So here 2g sin 30, here mg cancel, gg cancel. So equilibrium. No block will move. Okay. System is in equilibrium. Blocks are in equilibrium. So forces are balanced. Forces are balanced. Okay. Equilibrium. Newton's first law. Newton's first law. Now you tell. What is mg sin theta here? Tell me. What is mg sin theta? Tell me. 1 g sin 30, 1 by 2 g by 2. And what is mg here? 2g. So they are equal or not equal? Not equal. So system equilibrium or not equilibrium? Not equilibrium. Very good. So which is greater, g by 2 or 2g? 2g is greater. So which block will go up? 1 kg will go up. 2 kg will go down. Okay. So not down. 1 kg will move here. 2 kg will move. Now find acceleration. Acceleration you find. So this is g by 2, and what is this force here? Tension, and this is a 2g, and this tension is upward. So this is greater. So what do you write here? Greater minus smaller. Acceleration is a. Tell me what you write. 2g minus t is equal to ma. M means 2 kg. Okay, 2 into a. What you write here? T minus g by 2 is equal to ma 1a. Very good. 1. 5g by. Okay. So now you add this. Add add t minus t, cancel, minus g by 2 plus 2g, tell me. Tell me what you write. 2g minus g by 2, what is that? 2g minus g by 2, 3g by 2, okay, is equal to a plus 2a, so 3a, okay, 2 into 2, 4, 4g minus g by 2, 3g by 2 is 3a, 3 3 cancel, g by 2 is equal to 8. So acceleration is g by 2, note down, acceleration g by 2, okay, clear, okay, okay. So like this, more examples are there, okay. I will not finish this chapter very fast, okay. This whole week, I will, next week also this will continue. So this is what we are doing in this chapter, this topic: string, surface, block, pulley, correct? Normal force, tension force, acceleration. This is one part. The one more part is there. One part, another part is momentum and impulse. Okay, this is another part of laws of motion. Okay, so this also we will cover. Maybe 2 weeks it will take total. Okay, so August is there, so this whole month will go this only, laws of motion. Don't worry, this is a very important chapter. Don't think like that chapter is not finishing. Okay, don't think like that. It is a big chapter, okay, and important also. If we miss any topic of this, it is not good. Okay, cover all the topic of this: inclined plane, pulleys, okay. uh, so I will continue 15 more minutes, so note down. So this is over. So tension you got. What is tension? Tension. Acceleration you got g by 2. So what is tension? Use this. Use this. What is tension? Tension is equal to g by 2 plus a. So g by 2 plus a, which is g by 2. G by 2 plus g by 2, g means 10 Newton. Tension is 10 Newton. Note down. Tension is 10 Newton. Tension is 10 Newton. Okay, note down. Note down. You have to practice. Okay. I've told DPP yesterday you not got DPP. Okay. Today you ask, if they are not give, you ask. Okay. Give me DPP like that. Ask. Don't wait for them. Who has to write NEET? Them or me or you? Who is writing NEET? You. So who should be more responsible? You, right? You ask DPP. I want question. I will solve 30 questions today. Give me 30 questions. Okay. I have already given 3 days. I have given. Today I will give based on this 30 questions. So 12:30 today I am finishing 12:30. Tomorrow onwards I will finish 11:30. So 11:30 to 1 you solve questions. Okay. Solve DPP. Then your physics is finished. By 1 o'clock your physics is finished. Then whole day you can study other subjects. Morning to afternoon physics finish. Okay, are you getting or not? Try to finish physics work in the morning, afternoon. What is the best time to study physics? Morning. Okay, okay. Because your mind should be very fresh. Okay. By afternoon your mind becomes more burden, more stress. Okay. So that's why physics is best to finish early morning. Okay. Okay. Next we'll do pulley again. Two hanging blocks. Note down. two hanging blocks. Two hanging blocks and pulley. Again, same concept. It is very easy. Within 1 minute, 2 minutes, we can finish this topic. So, if M1 is equal to M2, what will happen? They will move or not? Not move, balance. So, equilibrium. They are in equilibrium. If M1 is heavy, so acceleration of M1 downward, acceleration of M2 upward. So M1 will accelerate down, M2 will accelerate up. Okay. If in, if initially they are at rest, if initially they are at rest, holding, rest, now you release. So M1 will go down, M2 will go up. Okay, like this. So what is the pulling force downward? Tell me pulling force. M1G, very good. Here what is the pulling force? M2G, very good. What is the upward force here? Tension. What is the upward force here? Tension. Now this is greater. So now you solve. Correct. So M1G minus T is equal to M1A. Very good. So acceleration of M1 is downward, acceleration of M2 is upward. Here which is greater? T is greater. So you'll write T minus M2G is M2A. Correct. Good. Now add these, add two equations, add. So minus T plus T cancel. So tell me what you get. So M1G minus T, M1G minus T plus T minus M2G is equal to M1A, M1A plus M2A, M1A plus M2. Okay, it's T minus T cancel. M1 minus M2, M1 minus M2 into G is equal to M1 plus M2 into A. So what is A? Tell me. M1 minus M2 divided by M1 plus M2 whole into G. Difference by sum. You can memorize like this. Difference by sum into G. So one direct question came in 22, I think 2022. One direct question came on this. Okay, they are asking acceleration. Difference by sum into G. Difference by sum into G. Now find tension. Use use equation 1. So M1G minus M1A is equal to T. Okay, first equation. Okay, find out, do it. So substitute the value, find A. A is difference by sum into G. Difference by sum into G. Now M1 minus M2 by M1 plus M2 into G. Put here. More you write, more you learn. Remember, our student life is like that only. We cannot learn without writing. Okay. Suppose you are simply watching like this, you will not learn. You have to write. Okay. Write. Keep a habit of writing. When you go to college also, MBBS college, how much you have to write? By that time, when you start practicing, how will be your writing? Have you seen doctors writing? They write how they write, so that no one understand, right or not? How doctors write medicine? Can you understand what they are writing? No. Why? Because doctors, imagine when doctor studying in college, school, how much they are writing, because that much knowledge you can get only when you are writing a lot. So your practice is like that. Okay, like you don't have time also. You have time, you will write physics like this. You don't have time, you will write physics like this, like this. Correct or not? Very less time you will write like physics. Correct or not? So like this, when you have doctors have more time or less time? Less time. Okay, doctors are time is very important. So doctors' life is like that. They are always busy. So that's why their writing is like this. Okay, because they have to write so much. Lot of things they have to write. So what is T? So M1G minus M1A. So A is this M1 minus M2 by M1 plus M2 into G. Now take G common, or you can simply solve this. So M1 M1 square G plus M1 M2 G. M1G common, yes, correct. M1G you can take common. Okay, good. Okay, let's take M1G common. So M1G common. So 1 minus M1G common. So M1 minus M2 by M1 plus M2. Okay, solve this. So M1G, now this will be M1 plus M2 minus M1 plus M2 divided by M1 plus M2, correct? Okay, minus M1 plus M2. M1 minus M1 cancel. So 2M2 M1G by M1 plus M2. So what is the formula for tension? T is equal to 2 M1 M2 G by M1 plus M2. Note down, this is the formula. So how will you memorize? 2 product G by sum. Okay. How you remember acceleration? Difference by sum into G. Tension 2 product G by sum. Okay, 2 product G by sum. And one more point. One tension is here also. One tension is here. So what is the net force? T downward, T downward. What is the net force? 2T. T plus T, 2T. So how much force clamp will exert? Clamp. How much force clamp will exert on the pulley? 2T. Okay. Pulley is massless. Okay, note down. Pulley is massless. So massless pulley. This is massless pulley. T massless. Mg not there. So clamp how much force exerting? 2T. And T is this. So you can write 2 into 2m1 m2 G by m1 plus m2. This is force exerted by a clamp. Force exerted by clamp. Okay, force exerted by clamp. Okay, so you start solving PYQs also. PYQs are very important. Okay, past year questions. Okay, PYQs. Some books are available in market past 30 years, past 40 years, past 43 years. Okay, you start solving them. So PYQ is also important. Okay, done. So just one question, and I will give you one NEET question also. PYQ you have? Give me PYQ. So we'll solve the question. So first, before PYQ, you solve this question. You solve this question. Here 2m. Here m by 2. Find acceleration. Find acceleration, find tension. Find force exerted by clamp on massless pulley. Find force exerted by clamp on massless pulley. So use direct formula. What is the direct formula for acceleration? Difference by sum into G. What is formula for tension? 2 product G by sum. Okay, so what is the acceleration here? What is the difference? Difference 2m minus m by 2. Very good. Sum. Okay. Sum is 2m plus m by 2, bracket close, into G. Tell me 3m by 2 divided by 5m by 2. Very good. M by 2 cancel. M by 2 cancel. So what is the acceleration? Correct. 0.6 G. 0.6 G. If G is 10, so your answer is 6. Okay, answer is 6. Now here what is acceleration? Difference. What is the difference? 1. Sum. Solve. This question, 2020 question is there. Okay. This book you have? We have everyone this book? Everyone? Okay. Page 31, question 76. Okay, same question. 2020. '87 also. 73 also. After this, you solve 80 also. 80, 75. Then you have 82, 86, 89, 90. You try these questions also. If any doubt, we'll discuss. Anyway, I will solve tomorrow also. So what is the answer for this? Acceleration 2. Okay. So acceleration is difference by sum into g. So 2. Tension is 2 product g by sum. So 2 into 6 into 2. So 24 Newton. Okay, good. Now find tension here. 2 product g by sum. So 2 by 4, 1 by 2. So how much tension? Tension. Correct? 15. How much force clamp is exerting? 2T. So what is the answer? 30 Newton. So 2 into 15. So clamp is exerting 30 Newton. Note down. Clamp is exerting 30 Newton. Okay. So this book is very important. 38 years. Start practicing. Okay. Don't waste time. Utilize your today, Sunday also you utilize. Okay, practice it. Time is precious. Don't waste time. Okay. Start solving. Have you finished a straight line? Motion in 1D. Motion in 1D. You have not finished? Finish it fast, quickly. By August, by September, your 11th question should be finished by at least 80%. Okay. So this book also you have to finish. Okay. So this relative velocity there. Okay. If any doubt is there, you ask. Kinematics equation is there. Graph is there. So I will revise these chapters. Some extra class also I will take. And all lectures are recorded also, so you can revise it. Motion in a plane is there. You finish it all. So like how many questions are there? 55 questions are there. Okay, finish all 55. You have to finish one by one. Don't think this is important, this is not important. Don't think, all are important. Sequence, go by sequence. Suppose you are not going by sequence, you can select odd number first. Like try 29, next you try 31, next 33. Are you getting? Suppose you are not following sequence, odd number you try. Then next Sunday, even. Finish odd first, then even. Like that you can do. Okay, so this is laws of motion. 90 questions are there, laws of motion. Okay, finish it. We'll continue.